What we want to do in this video is prove that if we have these two secant segments, AE and AC, and of course they both start from A over here, if we take the product, let's just start with secant segment AE. If we take that length and take the product of the part of the secant segment that is external to the circle, AD, so AE, that length, times AD, that should be equal to the product of the same segments on that other secant segment. So the whole thing, AC, times the part that is external, times AB. So let's prove this. And like we've done in many videos, we will do this by constructing some triangles. So let's set up a segment, I should say, BE, and then another one, DC. And what I want to show you now is that triangle ACD is, well, I'm going to show you it's similar, but I won't write it down just yet. But we're going to show that it's similar to triangle AEB. AEB. How do we show it similar? Well, we can see that this angle is going to be half the measure of this yellow arc right over here. Because if we have an inscribed angle, it is half the measure of the arc that it intersects. And this one also intersects the same arc, and it's also an inscribed angle. So we know that measure of angle ACD and measure of angle AEB are the same. We also know that angle A is in both of these triangles. So we have two congruent angles in both of these triangles. So we know that these two are similar because of angle similarity. Similarity is what gives us this conclusion. Well, that's really useful because now we can set up the ratio between corresponding sides of these two similar triangles. So we know that the ratio of, say, AD, the ratio of the length of AD to the length of AC, so that's the short and the long side that's not blue here. So AD to AC should be equal to the ratio of AB to AE. AB to AE. And now we can multiply both sides by both denominators, by both AC and AE, both those lengths. So AC and AE, this cancels with that cancels with that, and we are left with length of segment AE times length of segment AD is equal to length of segment AB times length of segment AC, which is exactly what we set out to prove.